With our second video in lesson number 6, where we talk this time about linear equations in 2 variables. And we already did the homework review, the pregame stretch, we reviewed that. Let's do some recent work recap, and then we'll get into the new material for today, the equation in 2 variables. Okay, so what I would like you to do first is evaluate these 2 expressions. Remember, while we're doing this, we're reinforcing old stuff, and we're also getting prepared for the quiz that we will be taking in just a little while. And you're doing stop and start, don't forget that. Do both questions, stop and start, and then I'll give you the answers. On my end, I'm going to wait 5 seconds. Okay. So for the first one, I substitute in an 8 and the 5 for x and y respectively. Negative 4 times 8 is negative 32. 2 times 5 is 10. Adding them up, I get negative 22. For number 2, I substitute in a negative 7 and a 4. On your quiz the other day, 2 students forgot to put negatives in parentheses with an exponent. Please don't forget that. I told you about Kevin Friend. Negative 7 squared is 49. If you don't do that, your calculator will say negative 49, and your answer is going to be wrong. 4 times 49 is 196. 9 times 4 is 36, subtracting 160. Okay. Next up, a point of emphasis. We're going to write some expressions based on real world kind of stuff. At one point in time, Eric Clapton had 5 times as many guitars, which gently wept, as George Harrison. Bruce Springsteen has 2 guitars less than Eric Clapton. If George Harrison had G guitars, write an algebraic expression for how many guitars Bruce Springsteen had. Seen here jumping from the piano, probably in his rendition of the song Jungle Land, which is an absolute classic with the best sax solo in the world. So reread that in front of you and write an expression for the number of guitars that Bruce had. Stop and start. Okay, so look, George Harrison has G, Clapton has 5 times as many, so that's 5G. And Springsteen has 2 less than that, so that's 5G minus 2. Okay, point of emphasis, the word from. Remember, from goes first. For example, if I'm on Thursday, I'm going to take a drift with a friend of mine. We're going to go for a drift on a drift boat, fishing for trout with streamers, brown trout, big brown trout in the West Branch of the Delaware. We're going to go from Stylesville to Balls Eddy. So where do we begin? What goes first? Stylesville. What goes last? Balls Eddy. So from always goes first. So you're going to try these 3 right here. Stop and start. I'll give you the correct answers in just a minute. Okay. 2 is subtracted from a number. The number has to go first. We get n minus 2. Next, from 15, subtract twice the number. 15 has to go first. Subtracting twice the number, or 2n. 1 is subtracted from twice the square of a number. So I've got to do 2n squared, then subtract the 1. So the big point of emphasis here is from goes first. When you see from and you got to write an expression, focus on the from, that goes first, everything else falls into place. Next, the point of emphasis is the word sum. Yes, sum means addition, but where you place that addition can be critical. Just based on where the word sum is placed, that very much affects how you express that plus sign. Is it in parentheses? Is it grouped? Is it not? So compare the examples below. Twice the sum of 9 and the number, the sum of 9 and twice the number. Notice the order changes. Twice the sum versus the sum of 9 and twice. So answer those 2, stop and start. Okay, so the first one, it says twice the sum. So first you have to do the sum of 9 and the number, that's n plus 9. Then twice that sum, 2 times. And that must be grouped together in parentheses. The next one says the sum of 9 and twice the number. So you're just going to add 9 and twice the number. So that's 9 plus 2n, but we really do like to put the n's first for reasons that will become apparent as the semester progresses. So that's, and everything's positive, so you could just use the commutative property and make it 2n plus 9. Next up, 5 times the sum of 3 times the number and 14. Go ahead. Okay, so 5 times the sum is 5 times the sum of 3 times the number and 14. So there's 3 times the number plus 14. Okay. Next up, a little practice with equations. Go ahead. Okay, assuming you did stop and start, we're ready to go here. This is the same side, same operation situation. On the left, we can get our h's together, and on the right, we can get our numbers together. So 8 h's and 2 h's make 10h. Minus 18 is 2h plus 22. Subtracting 2 h's from both sides gives me 8h minus 18 is 22. Adding the 18, 8h is 40. Dividing by h, and I get, by 8, I'm sorry, and I get 5. Okay, on the next one, we have to distribute that 3 first. That gives me 9k minus 15 equals 4k plus 25. So we're going directly to opposite side, opposite operation. So I always want to start with the smaller number of k's, or almost always. Subtract 4k from both sides. 5k minus 15 is 25. Add it. 5k is 40. And divide, and I get k is 8. Okay, so, what we've done here is we've kind of given a pretty rigorous review to all the things we've been doing so far. Things that by now you should be pretty comfortable with as I start to do less and less of that kind of work in class. What's that procedure for solving linear equations? First thing we always want to do is ask, is this a same side situation or an opposite side situation? You heard me say that in both of the preceding equations. You want to work toward a standard two-stepper. Once you get it in standard two-step form, business as usual. Isolate the variable and solve. And if they ask you to check, you always have to check in the original equation, not in the derived equation. So here's one where we, as Emerald would say, bam, kick it up a notch. Go ahead. Stop and start, of course. Okay. So I need to do some distributing here. That gives me 9n minus 12 plus 2n plus 14 minus 7n is 2n plus 16. So far, I'm looking pretty good with my work there. Now, same side, same operation on the left. So I've got 9n's and 2n's. That makes 11n's, and minus 7n's is 4n. And then negative 12 and 14 makes plus 2. So I get 4n plus 2 equals 2n plus 16. Now it's opposite side, opposite operation. Subtracting the 2n's. 2n plus 2 is 16. Minusing the 2, 2n's 14. Ding, ding, ding. N is equal to 7. Okay, so that's a nice equation. If you can handle that one, you can do pretty much any linear equation we're going to throw at you. I mean, we might throw some fractions in it. We might throw some decimals in it. Used to be a torment for students, but you know what? You have a calculator now. So the calculator will do the work just the same as if it were numbers that go into each other evenly. So it's what we're looking for here is a strategy on the algorithms that you're using. Next up, literal equations. So go ahead, solve all 8 of these literal equations where you solve for what they're telling you. So for number 1, it says solve for b, so make it say b equals. Number 2, solve for the variable x, make it say x equals, and so on. Do all 8 of those questions, of course, do stop and start, and I will put the answers up for you to check over or analyze your work. Okay, so here are the correct answers. You can see them before you. Look it over. If you have any lingering questions, perhaps I made a sloppy mistake. Lord knows I do it. Feel free to contact me via email and say, hey, what's going on here? Or maybe congratulate me and say, hey, you were pretty sharp today. Or if you feel the need, you can also talk to your friends about it. Okay? All right. And again, you just pause the video to see all the answers. Next up, 3 or 6, I should say, inequalities. Now, when you do these inequalities, you solve the inequality, you graph the inequality, and you express the inequality in, well, is this just, yeah, we didn't do bracket notation on these. So we'll do bracket notation on the next slides. So now it's just solve it and graph it. And let's have you do just letter A. Go ahead. Okay, so I'm going to add 10 to both sides, divide by the 3, and I get x is less than 7. there is my correct graph. Since it's strictly less than, there's no or equal to underneath. It's an open circle on 7, and as long as the variable is on the left, like the n is here, the direction of the arrow, in black there, thick black, will always be in the same direction as the inequality. Okay, that's why we want the letter on the left. Okay, let's try letter B. Go ahead. Okay, subtracting 2. 2n is greater than or equal to 14. Dividing by 2, n is greater than or equal to 7. And since it's greater than or equal to, I fill in the circle, arrow to the right. If you're looking for a cheap, cheesy way to remember that if it's or equal to, then you fill the circle in. You can always take the extra ink for the equal to and fill in the circle. See, that ink is missing from the strictly less than, but you have extra ink with the greater than or equal to. It's the or equal to that gives you the extra ink, and that is what you use to fill in the circle. Okay, the letter C. Go ahead. Okay, so I subtract 3 from both sides. I get x over 5 is less than 4. Multiplying by 5, x is less than 20. And there's my graph. Again, notice my variable's on the left. The direction of the inequality is the same direction as the arrow that we draw, or the line we draw. See it also on letter B. Letter's on the left, arrow points to the right, I draw the line to the right. Okay? All right, and you know, the thought occurred to me while I was waiting on this one is when I say if you multiply or divide by a negative, which you're going to need to do here in number 1, you switch the direction of the inequality. It's only when you multiply or divide by a negative. Unfortunately, I don't have any examples in here of going into a negative. I should have made some and I didn't do it. It doesn't make any difference what you divide into. It only matters what you multiply or divide by. So multiply or divide into a negative may or may not change the sign. Doesn't make a difference. It all depends what we're multiplying or dividing by. Do it by a positive, you don't change the sign. Multiply or divide by a negative, you do change the sign. Okay, number 1, go ahead. Okay, so I subtract 8 from both sides. Negative 3n is less than 3. Dividing by negative 3, and I get n is greater than negative 1. So notice here, I divided by a negative, so I have to switch the direction of the inequality. Oh, this should say negative 1, not negative 2 down here. There's my daily dumb mistake. Second one of the day. Arrow goes to the right. You can see that. It's just that this should be a negative 1. Okay, next up, number 2. Go ahead, solve it, and I'll show you the steps in a couple of seconds, my time. You're stopping and starting. Okay, so 15x plus 35 minus 2x plus 3 is less than or equal to 7x. I distributed. Same side, same operation. That's 13x's plus 38 is less than or equal to 7x plus 50. Subtracting the 7x, I get 6x plus 38 is less than or equal to 50. Now I subtract 38 from both sides. I get 6x is less than or equal to 12. Dividing, and I get x is less than or equal to 2. Am I going to fill the circle in on this? Yes or no? Yes. Is 2 an answer to this question? Absolutely, because it is or equal to. On the previous question, is negative 1 an answer to that question? No, it is not, because it is not allowed to be or equal to. And there is my graph. Notice, circle's filled in, arrow to the left, x is on the left, so it goes in the same direction. Okay, number 3. Go ahead. All right, so I subtract 5 from both sides. I get x over negative 4 is less than 3. Multiplying both sides by negative 4, x is greater than negative 12. Is negative 12 an answer to this one? No, because it doesn't say or equal to. And that is why, when we graph this guy, it's an open circle. If you want to look for the cheap, cheesy trick to remember, there is no line underneath to fill the circle in, so I don't fill it in. Looking back at number 2 here, there is extra ink underneath, so I fill the circle in with that extra ink. All right, so those are inequalities, solving them, remembering about If you multiply or divide by a positive, the sign stays in the same direction. And if you multiply or divide by a negative, the sign switches. And it's only multiplying or dividing by. It doesn't matter what you go into. It's only by. Okay, so what I want to do now is have you take a look at these two and have you write the bracket notation for the number line graphed on the left and also the one on the right. Go ahead. Okay, so on the left, I want you to notice particularly that this is a filled in circle. So I'm going from negative infinity to -1. I can include it, which means I need a bracket on the right, but I never use a bracket with an infinity. So I use a parenthesis with an infinity. So it's from negative infinity to -1. And if I wrote it as an inequality traditionally, that would be n is less than or equal to, because it's allowed to equal it by the filled in dot, -1. Okay, for the second one, I'm going to pause just in case you want to make any adjustments here. Okay, for the second one, its n is greater than 3. It's not or equal to because the circle is open. And since it's not or equal to, I use a parenthesis at 3 and I go on to infinity forever and ever and ever based on how that arrow is drawn. Now, this is something that we didn't exactly do, but I think you can figure it out without us doing it, okay? So what I'm looking for here is these are both the same answer. Notice the top one is how we would traditionally graph it, kind of like the one on the right here that we did just above it. And the second one, instead of using an open circle, which is traditional, some mathematicians have started to use either a parenthesis or a bracket. So here's a parenthesis, kind of getting at combining the graphing and the bracket notation. Either way, both of those graphs mean x is greater than 8. Okay? All right, so a little bit more review here. The parenthesis means it's not included, or we could use the word exclude, and the bracket means it is included. It is allowed to equal it. You see we have the top and the bottom of a bracket look like an equal symbol. So in this first graph, they're both open circles, so these both have to be parentheses. In the middle graph, the one on the left is filled in, so it has to be a bracket. The one on the right is an open circle, so it has to be a parenthesis. And then on the bottom, they're both filled in, so they're both brackets. And in all three questions, they begin with 1 through 5. Okay? So with these ideas ruminating around your mind, let's have you try to express both of these in both bracket notation and with an inequality. Go ahead. Stopping and starting, of course. Okay, so for the first one, its n is less than or equal to 3 because notice there's a bracket on 3. A bracket is just like a filled-in circle. And, of course, we're starting out at negative infinity, so we have to have a parenthesis and a bracket at 3. That's the advantage of this technique is the bracket. You just bring it on down. As far as the next one goes, is this going to be a bracket at -2? No, it's going to be a parenthesis. What about at 5? That's going to be a bracket, or an or equal to, and a strictly less than. So there's my two answers there. Okay? All right, so that reviews everything that we have gone over so far, and I hope you're feeling pretty comfortable with it. I think you're doing pretty well. The quiz will definitely tell.